Hello everyone, welcome to Coders Camp. We are at 7th day of October LeetCode Challenge, and the problem we are going to cover in this video is word search. So the input given here is m cross n grid of characters and a string word, and we have to return true if the word exists in the grid. And we can construct the letters of sequential adjacent cells only if the cells are horizontally or vertically neighboring, and the same letter cell may not be used more than once. So let's understand this with an example. So the word we have to find here is C. So the rule said that the word can be constructed only if the characters are horizontally or vertically neighboring. So here there is an yes to start search our word, but all the characters neighboring to yes, both horizontally as well as vertically, or not E. So we are going to search for another yes exist in the grid. So if you see, there is one more yes here that has E's in the neighboring both the sides, that is upwards and downwards vertically. So we can search, proceed with both the E's. So let's start with the E in the first row. From this E, if you see, there is only one neighboring character that is horizontally, which is C. So this cannot be the word given. So we are bouncing back to our search in the other path. There is one more E here. So let's look from this E. What are the neighboring characters? Only neighboring characters is characters under E. So we have found our word here and we have to return true. So how are we going to approach this problem? Like any other grid problem, either it can be integer grid or character grid, it is going to be BFS always if it comes to finding a path or finding a maximum or min path, anything with the grid. So again, we are going to use a BFS and a bit of backtracking to solve this. So let's see how are we going to do that. As I said, the problem is again going to work in a very similar way. We are going to start with the very first character and search for the character and proceed from that path. So we are going to start from this yes, because this is the first yes as we iterate from the very first character in the grid. So we are going to stick to this yes and further explore all its neighbors. So if you see, it can be checked only horizontally or vertically. So there are only three options, and all the three options are not the next character in the string, which means this way it cannot be constructing the given string. So we are skipping this and moving towards our search in the next characters in the grid. So if we see the next character, F is not the first character in the given word, C is again not the first character. So again there comes a yes. So we are going to pick this particular position and check for its neighbors. The possible neighbors are C, E, and E. So if you see the second character that matches the second character in the given word. So the possible paths can be this E or the other E. So we are going to further stick to this E and proceed. So before that, there is another condition given in the problem statement is the same characters cannot be picked again for the same word. So to avoid that, you either can maintain a similar matrix, a Boolean matrix visited as usual to set true or false whether this cell is visited or not. So that is going to cost us again a big go of n space complexity, because we need one more matrix to store the true or false values. But instead, we can do a small trick to use the existing array, and so to perform that, instead of having a separate matrix, I'm going to update with a asterisk sign instead of the existing character to see or to confirm that cell has been already visited. So we have visited S, so I am updating with the asterisk sign. So now we are taking the next path and we are going to update an asterisk sign again. So we are going to explore from this particular position to check whether it has a neighbor with another E, because that is the third character in the word. So if you see, there is only one neighbor to E, that is C, which is actually not the third character in the given word, which means this path cannot be the path we had come for. So we have to backtrack to the next path which has another E which matches the second character. So before backtracking to the another path we have found the second character, we have to replace again this asterisk sign with E. Why? Because if we found or further exploring in the same path and we did not find our character and we have to come back to the same position and again start with the same path, we might happen to use the asterisk symbols again for our word. So to avoid the confusion, once we did not choose this path, we are again going back to update the character back to its position. So getting back to this E, again we are going to explore from this point. So we are updating this position with an asterisk sign. And from here we are checking its neighbors. So if you check, the only neighbor to this E is another E, which actually matches the third character in our given word. So since the last character matches the another character in the neighbor, which means the word is complete and we reached the last character, so it's time to return true since we found the word in our grid. So this is nothing but a basic DFS code with recursion, and just that instead of using an extra visited boolean matrix, we are updating the asterisk sign to avoid the extra space and achieve it in constant space complexity. So hope you're understanding this concept. Let's go to the code. So here's the code for this problem where we are going to iterate each cell here in the given input board and passing that to match whether it is the first character and or it is the starting point to find our word. So if and we have a helper method exist, and if it returns true, then we are going to return true. If not, we are going to return false. The main method is as simple as that. So let's concentrate now on the exist method. So this method would do a DFS to check whether any path matches our given word. So as I said, this would be our base condition, whether we reach the last character of the word, which means we found our word, so we are going to return true. Otherwise, this is again a simple validation where we are checking whether our indexes are at the right position. If not, if we have crossed either the greater than the length or height of the grid, or if it is less than 0, or the word that did not match the next word in the given input word, then return false. If not, if we found a match, then we are going to update it with star so that it won't be considered again for the word. And then we are calling the same method recursively for all its neighbors. So upward, downward, and left and right, since it can travel only horizontally or vertically. So here this cases will be nullified if it exceeds the limits. If not, it is going to process and find for the next word in its neighbor. So if any path is true, which means our word has been found in one of the paths. So we are keeping a or symbol that if any of the case is true, which means we found our word, and then we are going to return our result. Our result would be if it reached the last character, then it would be true. So here we have another statement of replacing the word again. So if not, once we update with star and the path further proceeds, we have this point to backtrack or redo our star back to the character. And finally, we return the result. So yes, this is it. This is again the basic DFS code we use all the time. So let's run and try. Yes, so let's submit. Yes, we solved our today's problem and it runs in 98 milliseconds and which is 72% faster than the other solutions. So thanks for watching the video. Hope you like this video. If you like this video, hit like, subscribe and let me know in comments. Thank you.